Hi everyone, this is Amy from the Helms Academy, and today we're talking about the area of polygons. By the end of this lesson, you'll be able to define area, identify some different types of polygons, and find the area of those types of polygons using the formulas we'll learn about. Let's get started. Before we really get started, I want you to take a moment to think about and imagine that you have a whole bunch of sticky notes. Now, I want you to look around you and find a wall or another flat surface near you. And I want you to think, how many sticky notes would you have to put on that wall or surface to cover the whole thing? When you're thinking about calculating area, that's a good visual to hold on to, because the units that we use to measure area are units squared or square units, which means that could be in feet or inches, meters, miles, any other kind of distance measurement as the unit. We add that word squared because we're calculating the total area using square measurements. So if we're talking about a square inch, that means that it's an inch on each side, and that's 1 unit of measurement, similar to how a post-it looks. So if you want to cover a whole area, you will need to have enough of those smaller squares to cover that area. That will be the total area amount. We see 9 boxes inside the square that you see on the screen, and that means that the area of that whole box, the full thing, is 9 units squared. If I were trying to decide how much material I needed to cover that space, or perhaps paint or wallpaper, this would really help me to figure out what's the total space so I can get the correct measurements on whatever it is I'm using to cover that space. Now, let's talk about a few of our important key terms. When we talk about area is the measurement of a surface. And we'll talk today about different polygons. Now, a polygon is a two-dimensional shape with 3 or more sides and angles. So some of the examples of that would include a square, a rectangle, a triangle, a parallelogram, a trapezoid. So in the coming slides, we're going to look at each of these shapes and determine how to find the area of each. Let's begin our area journey with squares and rectangles. So a square is a 4-sided shape, and all the sides have the same length, and all of its corners make right angles or 90-degree angles. The square here is labeled with one side as 9 centimeters, but none of the other sides are labeled. And that's okay, because we only need one side's length to know what all the sides are, since all the sides we know are equal. So you'll see the equation at the top, A equals S squared. And this means the area of a square means the length of one side squared. So in this situation, we'll put in our value of 9. We know 9 centimeters is the length of the side. And we'll put the squared beside it. A equals 9 squared. Well, 9 squared is 9 times 9, and we know that equals 81. And to finish it off, we're going to put the measurement, which is centimeters, and then the squared. Great, there's our area of a square. For the rectangle, we're going to be doing area equals length times width. You'll see A equals LW. Remember, when the two letters like L and W are next to each other, it means that we're supposed to multiply them together. So think of it this way. We have a rectangle that has one side that is 8 miles long and another side that is 5 miles long. So to get our total area, we just need to multiply those two sides together. Right? One is the length, one is the width. So 8 times 5 is 40. So we know our area is 40, the unit, miles, and then we always have to add that little extra piece, squared, at the end. Let's move on to triangles. So a triangle is a polygon with 3 sides and 3 angles. Here we see that the formula to find the area of a triangle is half times base times height. So remember, multiplying by half actually makes a number smaller. It does the same thing as dividing the number by 2. So you can think about that when you're completing these problems. The number should be smaller than just the base times height together. All right, so the triangle in the bottom left corner shows us two measurements, 7 as the base and 10 as the height. So we plug those numbers into the formula and multiply. So half times 7 times 10 equals 35 yards squared. Always be sure to include that type of measurement, yards, and the squared at the end. For the other triangle, we see the base at the bottom is 10 inches and the height is 8. So we multiply half times 10 times 8 to get 40 inches squared. A parallelogram is maybe an uncommon figure to many of us. It's not a word that we use all of the time or shape that we find very often. But the unique thing about a parallelogram is that it has 4 sides and all of the sides are slanted so that they're parallel to each other. So the 2 sides on the left and right are parallel and the 2 sides on the bottom and top are also parallel. So the other thing that's unique about it is that none of the angles are 90 degrees. So whereas a rectangle or a square have those sharp 90-degree angles, all of the angles on a parallelogram will be either larger or smaller than 90 degrees. Now, to get the area of a parallelogram, we just have to do base times height, and that's it. So for the first one, we see the base 6 times the height 4. So this means 6 times 4 is 24 feet squared, and that's our total area. All right, for the second one, again, just the base at the bottom, that bottom measurement along with the height of the figure. So we know the base is 7 inches and the height of the figure is 3, and 7 times 3 is 21. So the area is 21 inches squared. For a trapezoid, the formula looks complicated, but I promise that once we plug in the numbers, it's really nothing to worry about. We just need half times the 2 bases added together times the height. Or to put it in another way, like you might see on the GED Formula Sheet, half times the height times the sum of the 2 bases. Both the formulas are the same and you'll get the same answer. They're just written in a different order. Today we'll use the second one. So let's look at the first trapezoid. To find the 2 bases of a trapezoid, we need to look for the 2 parallel lines. In this case, our trapezoid is set on its base, so the bottom and the top are parallel to each other. And that means the lines at no point get any closer or any further away from each other. They're always the same distance across. So we have our 2 bases, 9 and 6. And then we need to find the height of the trapezoid, which is 4 feet. So to get the area, we now need to do half times the height, 4, and add together our 2 bases, 6 and 9. According to the order of operations, we always do parentheses first. So we know that 9 plus 6 is 15. So now we multiply from left to right, half times 4 times 15, which is 30. So the area of our trapezoid is 30 feet squared. So our next trapezoid has a height of 9 and 2 bases, 8 and 12. So let's plug that into the formula. Half times 9 times the sum of 12 and 8. So we know that 12 plus 8 is 20, and now we can multiply that all together. Half times 9 times 20 equals 90. The area is 90 feet squared. For all the formulas that you learned today, I want to remind you that they will be on the formula sheet that you'll have during your HiSET or GED math test. You can also search them online to take a look at them ahead of time and know what resources will be available to you during the test. Thank you so much for watching today. Don't forget to subscribe to our YouTube channel. You can also check out the Helms Academy on Instagram, Facebook, and at helmsacademy.org.